1 minute. Yeah. Now, in this phase rule, as I told you, it is related to thermodynamics because this phase rule was given by a famous scientist, Gibbs. Okay. So it is the Gibbs phase rule. Based on this Gibbs phase rule statement, we are going to do the further topics. Now, under the Gibbs phase rule, there is one statement. Then we are going to do numericals on phase equilibrium. Then we are going to study one component system and two component system. We will be doing numericals on two component system, and lastly we are going to just study the applications and limitations of phase rule. Followed? So one by one we will study. We will come to know what is one component, what is two component, what are the different parameters or the factors which governs this phase rule. Okay. Now let's come to the part one by starting with the Gibbs phase rule. Okay. Generally we have अभी हमने ये polymer में भी देखा था, conducting polymers में, where the conduction is carried out in the electrical phase, or somewhere in atomic and molecular structure we studied about magnetic phase. Some certain areas are governed by the magnetic field. ये सब अभी अब तक हमने पढ़ा है, लेकिन अभी हम जो पढ़ने जा रहे हैं वो पूरा entire system is not at all governed by or ruled by gravitational force, nor it is ruled by magnetic force, nor it is ruled by any kind of surface action theory and all that. This system is completely governed by temperature, pressure and concentration. That is, when one particular situation, like as I told you, when water is being converted into ice. Okay. So here the major factors or the parameters which are required is the temperature, the pressure, and how much concentration of the material has been used. So here the Gibbs phase rule says that only. Okay, so whatever we are studying it in the stage of equilibrium. So no matter the equilibrium stage is there, the number of phases, okay, from one phase to another phase में जब conversion होता है, जितने भी phases होंगे उसमें, they are definitely not influenced by any kind of gravitational, electrical or magnetic forces, neither by surface action. They are only influenced by temperature, pressure, and concentration. So when this particular phases, they are ruled up by temperature, pressure, and concentration, then the number of degrees of freedom of the system is related to the number of components and phases by the phase rule equation. Now this is very theoretical definition. अभी इसमें आपको बहुत कुछ ऊपर का पार्ट तो समझ में आ गया होगा कि ये रूल करता है by temperature, pressure and concentration. But then what is degree of freedom? What are the components? What are the phases actually? ठीक है, ये चीज हमको अभी जानना है. But this is the phase rule. ये phase rule के ऊपर ही हम लोग सारा कुछ आगे का theory पढ़ने वाले हैं. What is the phase rule? Provided equilibrium between any number of phases is not influenced by gravitational, electrical, magnetic forces nor by surface action theory. It is influenced only by temperature, pressure, and concentration. So when these factors come up, there are certain other factors which is related to this temperature, pressure, and concentration. What are these factors? These are the number of degree of freedom of the system is related to the number of components and phases by the phase rule equation. So what is phase rule equation? Phase rule equation is F is equal to C minus P plus 2. This is the phase rule equation. F is equal to C minus P plus 2, where F is the number of degrees of freedom, C is the components, P is the phases. And what is 2 standing for? 2 is actually standing for these 3 factors, that is temperature, pressure and concentration. तो ये 3 फैक्टर है, लेकिन मैंने यहाँ पे +2 लिखा है. The reason is that for writing +2, at the most 2 factors should be present whenever any kind of reaction is going on. Not necessary 3 factors हो. 3 में से minimum 2 factors are required. That's the reason this is +2. Followed, F is equal to C minus P plus 2, where F is the degree of freedom, C is the number of components, and P is the number of phases. How this FCP is defined, that we are going to see it further, but this is the phase rule equation. Please write down. So based on this rule, we are going to carry forward our further topics. Okay, please write down the Gibbs phase rule and the equation. Based on this equation, we will be finding out the F, the C, and the P. Okay, so now with this Gibbs phase rule equation, now let us study what is actually F, what is actually C, and what is actually P, and how they are ruling this particular system in the equilibrium state. Okay, very easy. Yeah, if you understand it, very easy. मैं आपको logically समझाऊंगी. Theoretically, if I try to explain you certain things, you may not understand. So logically, I'm going to take this particular topic. Now, P is the number of phases, F is the degree of freedom, and C is the number of components. First, let us study what are phases. If you see this theoretical definition, phase is defined as a homogeneous, physically distinct, and mechanically separable portion of a system, which is separated from other such parts of the system by definite boundary structure. Now I'll tell you what is actually phases. आपको पता है 3 states है मैटर के, 4th state भी है प्लाज्मा. Okay, the first one is solid, liquid and gaseous state. ठीक है, ये चीज यहाँ पे अप्लाई होती है. In short, phases are nothing but the solid phase, the liquid phase and the gaseous phase. समझा? Phases are nothing but the solid phase, liquid phase and gaseous phase. They all are different from one another, physically distinct है वो, एक दूसरे से अलग है. Solid को आप देख के बोल सकते हो this is the solid phase, आप identify कर सकते हो. ठीक है, तो एक अगर homogeneous system है या फिर तो वो जो solid है वो एक homogeneity है, लिक्विड एक होमोजेनिटी है और गैसियस एक होमोजेनिटी है. इन तीनों को कंपाइल करेंगे तो बनता है हेट्रोजीनियस सिस्टम. फॉलोड? समझा? एंड वी आर एबल टू separate this solid from the liquid and from the gaseous state also, and this separation should be done mechanically. Okay, so what is phase? Phase is the homogeneous, physically distinct, that is a solid, liquid and gaseous, and mechanically separable portion of the system. When we look at the equilibrium system, we will come to know, okay, this is solid phase, this is liquid phase, and this is the gaseous phase. When they are together in a particular system, we call this system as heterogeneous system. But अपने आप में solid is a homogeneous, liquid is a homogeneous system, and gaseous is a homogeneous portion of the system. Followed, everyone? So with this, let us see the first example. Water. Now, water exists in 3 different forms. When it is solid, we call it as ice. When it is liquid, we call it as water. When it is gas, we call it as water vapor. Correct, students? I want your response.
Yes, ma'am.
Okay. So here we say water has got 3 phases. That is, one phase is solid, one phase is liquid, and one phase is gas, which exist together in the equilibrium state. Okay? So overall, it is a heterogeneous system, but also maintaining homogeneity. That is, solid is one, liquid is the second phase, and gas is the third phase. So water has got three phases. Okay, let's take another example. This one over here. I've just written water in equilibrium with water vapor. Now, how many phases are over here?
Two, ma'am.
Yes, one is liquid and the other is gas. Okay, please write down the topic as phases. Phases लिखो, definition मत लिखो, definition is available in the notes. Just write down phases, which is in short represented as P, and do these examples. Let me know after completing. तो इस तरीके से ना आपको जब न्यूमेरिकल्स आएगा या फिर बोला जाएगा just write down the number of phases, components and degree of freedom, there they will give the equation, जैसे कि ice to water vapor. So we know this is solid, this is liquid, and this is gas. So we are able to define, okay, over here in this particular system in the equilibrium, there are three phases existing. If water and water vapor is given, then there are two phases existing. Done? Then let me know.
Done.
Shall I change them? Yeah. Let's take another example. Okay. Now tell me air. Air is a mixture of many gases. Correct? Air is a mixture of many gases in it. There is nitrogen, there is oxygen, there is carbon dioxide, there is hydrogen. There are many gases in it. Now, wherever you are sitting right now, in a room you are sitting, can you just tell me, okay, in that corner there is nitrogen gas floating, in that corner there is oxygen gas floating in the air. Can you just tell me?
No, ma'am.
Not at all. So here, even if there are n number of gases in a system, we still say the number of phase in any mixture of gas is 1, because all gases mix freely to form a homogeneous single system. We just cannot look at the gas in a room or look at the air in the room and tell, okay, there is nitrogen, there is oxygen, there is hydrogen or carbon dioxide. We cannot say. Okay, so whenever there are, please mute yourself. Whenever there are mixture of gases present, we say it forms a homogeneous system, and the number of phases is just 1. Okay, followed? ओके तो जब भी गैसेस आएगा जैसे ऑक्सीजन प्लस नाइट्रोजन और H2 plus O2 gives H2O which is water vapor, remember it is phase 1, number of phases is just 1. ठीक है? Let's see another example. Miscible liquids. Miscible liquids means what? Can anyone tell me? Miscible liquids means what? बोलो.
Ma'am, that miscible liquids which form some bubbles after mixing in it. I think
No.
do not mix.
No. Mix होने के बाद क्या होता है?
Mix together.
वो something bubble जैसा structure form होता है ना.
लेयर्स
वो
फॉर्म
तो
हो जाती
वो
है।
एफरवेसेंस है, यू आर टेलिंग एफरवेसेंस। नो, व्हाट आर मिसिबल लिक्विड्स? आई डोंट वांट द करेक्ट डेफिनेशन, लेकिन होता
मैम
क्या है
one
मिसिबल
can
लिक्विड्स
mix
में
together
कंप्लीट
with
होते हैं।
water and ethanol.
ओके, उससे क्या होता है? मिक्स तो होगा। मिक्स तो जैसे कि मिसिबल लिक्विड्स होता है और दूसरा होता है इमिसिबल लिक्विड्स। मिक्सिंग तो दोनों में ही करते हैं। What happens, there are certain solutions. There are, let's say for example, two different liquids. Yeah. ये two different liquids को जब हम mix करते हैं ना, it forms a single solution. Okay, it forms a single solution. Single solution का meaning क्या है? One liquid mixes with the other liquid very nicely, and then it is difficult to to differentiate. Okay, this is that liquid A and this is that liquid B. ठीक है, तो वो इतना अच्छे से मिक्स होते हैं, डिसॉल्व होते हैं कि वो लिक्विड्स को हम बोलते हैं मिसिबल लिक्विड्स। फॉर एग्जाम्पल, वाटर एंड इथेनॉल। वाटर को इथाइल अल्कोहल से मिक्स करते हैं तो वो एक सिंगल सोल्यूशन बनाता है, और वो सोल्यूशन को देख के हमें कभी पता नहीं चलता है कि ओके इसके अंदर वाटर और इथेनॉल है। वी जस्ट कैनॉट आइडेंटिफाई एट ऑल। ठीक है, दैट मीन्स टू डिफरेंट लिक्विड्स दे आर मिक्सिंग एंड डिसॉल्विंग इन वन अनदर। तो ये डिसोल्यूशन कंप्लीट हो तो वो लिक्विड को हम बोलते हैं मिसिबल लिक्विड्स। तो ये लिक्विड जब मिक्स होते हैं, डिसॉल्व होते हैं कंप्लीटली एक दूसरे में, तो इट इज डिफिकल्ट टू सेपरेट mechanically these two liquids. Can you separate water from ethanol just by looking at it? Can we do filtration or something like that? No, we cannot. So such liquids which mix with one another and form a single solution, we say, though there are two liquids, but still we say there is only one solution which is present in the liquid state. Therefore, the phases is equal to 1 in miscible liquids. So number of phases, remember every time, number of phases in miscible liquid is just 1. Followed? समझा यहाँ पे? Let's take another example then. Immiscible liquids, water and oil. आप पानी लो और ऑयल को उसके साथ में मिक्स करो. Keep on shaking it. You try to mix it a lot, it will never mix up. When you keep it for undisturbed for 5 minutes, water और oil का जो layer है, वो दोनों layer separate हो जाएंगे. आप easily just by looking at it, you can identify this is the oily layer and this is the water layer. आप करके देख लो, ऑयल और वाटर कभी मिक्स नहीं होते हैं, कितना भी आप उसको करो कोशिश. So such liquids we call it as immiscible liquids. What do we call it as? Immiscible liquids. और यहाँ पे हम वाटर का लेयर, वाटर का एक लिक्विड लेयर आइडेंटिफाई कर सकते हैं और ऑयल का एक लिक्विड लेयर इजीली आइडेंटिफाई कर सकते हैं. तो दो लिक्विड्स को हम इजीली एक सोल्यूशन में जब आइडेंटिफाई कर सकते हैं, वहां हम बोलेंगे नंबर ऑफ फेजेस इज 2. क्या बोलेंगे हम? नंबर ऑफ फेजेस इज 2, जबकि वो दोनों लिक्विड ही है, लेकिन दोनों लिक्विड को हम इजीली आइडेंटिफाई कर सकते हैं, सेपरेट भी कर सकते हैं. ठीक है, तो दो लिक्विड्स जो अलग अलग तरीके से अलग अलग लेयर में प्रेजेंट है, उसको हम आइडेंटिफाई भी कर सकते हैं, तो वहां हम बोलेंगे नंबर ऑफ फेजेस इज 2. फॉलोड? अगर दो लिक्विड्स मिक्सअप हो रहे हैं, then we say such liquids are miscible liquids. And just by looking at it, we cannot say, okay, this is water, this is ethyl alcohol. We cannot say. So here the number of phases become 1. So in short, जितने भी miscible liquids है, उनका number of phases 1 है. जितने भी immiscible liquids है, उसका number of phases जो है 2. Okay. Proceeding further. Aqueous solution और saturated solution. जैसे कि शुगर हमने लिया, शुगर को पानी में मिक्स किया, शुगर पानी में डिसॉल्व हो गया, या फिर इसी तरीके से NaCl सॉल्ट लिया, उसको पानी में मिक्स किया, NaCl got dissolved. So such solutions we call it as only one solution. Okay, so number of phases over here is 1. Okay, so just do this examples.
मैम लास्ट वाला फिर से
हाँ, जैसे कि हमने
हाँ।
शुगर लिया, शुगर को हमने पानी में मिक्स किया, so we got sugar solution, so that is one single solution, right? Okay, so here we say number of phases is 1. वैसे ही हमने सॉल्ट ले लिया, सॉल्ट NaCl, उसको वाटर में मिक्स किया, we are getting the salty solution, so that salty solution के लिए number of phase is just 1. Okay,
ओके मैम।
तो ऐसा क्वेश्चन अगर आया तो नंबर ऑफ फेज 1, कुछ अलग तरीके से उन्होंने क्वेश्चन दिया तो वो भी एग्जांपल में आपको देती हूँ आगे, इतना आप कर लो पहले।
Yes, ma'am.
Now here comes the 6th example, allotropes of sulfur. Now allotropes of sulfur exist in these 4 different forms, that is rhombic sulfur, monoclinic sulfur, liquid sulfur, and sulfur vapor, which is gaseous state. So one sulfur is just existing in 4 different forms. 2 are solid, which are different from one another. I repeat once again, rhombic sulfur, monoclinic sulfur, they are different from one another, so they are 2 different solids. Then there is the third one, liquid sulfur, and the fourth one, gas sulfur. So here we say the number of phases are 4. Because what do phases tell us? It is a heterogeneous system which is mechanically separable portion. The solid can be separated from other solid, from the liquid, and from the gas. These 4 can be separated. So 4 different phases of sulfur. Okay. Let's say another example. This is the best example if this type of equation is given. Calcium carbonate on decomposition due to heat produces calcium oxide and carbon dioxide. Okay, so calcium, this is in the equilibrium state. Okay, so calcium carbonate is one solid, calcium oxide is another solid, and carbon dioxide is the gas. So how many phases are existing over here?
2.
2 phases.
No. That's what I told. This is calcium carbonate, which is in the reactant side. ये अपने आप में एक solid है. ये जो calcium carbonate convert हो रहा है into the other solid, calcium oxide. तो हमेशा solids को अलग अलग phases में count करना है, क्योंकि ये जैसे कि rhombic sulfur एक solid है, monoclinic sulfur दूसरा solid है, तो इसको हम एक solid कैसे बोल सकते हैं? दोनों अलग अलग है, ठीक है, क्योंकि ये दोनों मिक्सअप नहीं हो रहे, ये दोनों अलग अलग है, ठीक है। तो फिर दिस इज व्हाट इज रिटन नो इन द डेफिनेशन, फिजिकली डिस्टिंक्ट का मतलब क्या है? दोनों भी अलग अलग है। वेरी वेरी दिस इज सी ओवर हियर, होमोजीनियस फिजिकली डिस्टिंक्ट मीन फिजिकली दोनों का अपीयरेंस अलग होना। सॉलिड, एक रोम्बिक सल्फर सॉलिड है और एक मोनोक्लिनिक सल्फर सॉलिड है। वैसे ही कैल्शियम कार्बोनेट एक सॉलिड है और कैल्शियम ऑक्साइड एक सॉलिड है। So number of phases is 3. ठीक है, लिखो इसको। So if they are clearly specifying it that calcium carbonate decomposes to calcium oxide, which is giving other solid, then carbon dioxide gas is released. तो ये clear indication equation पे दिया है कि ये अलग है, ये अलग है। But then look at the 8th example, a mixture of calcium oxide and calcium carbonate. So again there is calcium oxide which is one phase, calcium carbonate is another solid which is another phase. यहाँ पे कार्बन डाइऑक्साइड का कुछ भी स्पेसिफाई नहीं किया 8th example में. So here we will write down सिंपली नंबर ऑफ फेजेस इज इक्वल टू 2। तो क्वेश्चन में जो दिया है उसको देखना है और लिखना है, उसका पूरा बैकग्राउंड थ्योरी
Repeat,
याद
ma'am.
करना या फिर उसका रिएक्शन में क्या हुआ था ये सब सोचने की जरूरत नहीं है। जो क्वेश्चन में दिया है सिंपली उसको देखो और लिखो। ठीक है, डन। Shall we proceed?
Yes, ma'am.
Okay. Now we have understood what are the number of phases. Now let's see the number of components. First, we will see the theoretical statement of it. What does components say? Components बोलता है कि I am the smallest number of all the maximum numbers. Maximum numbers को नहीं देखना है. I am the smallest number of independently variable constituents. ठीक है, taking part in the state of equilibrium by means of which the composition of each phase can be expressed directly or in the form of chemical equation. Now, if I tell you what are these constituents are nothing but the total number of reactants and total number of products. Logically, I'm telling you. If you go with the definition, if you try to identify with the concept, it is a very deeper concept, which you may get confused also. तो इसी के लिए logically मैं आपको क्या देखने के लिए बोल रही हूँ, just concentrate on the number of reactants and the number of products. The total number of reactants and products are nothing but the number of components, in short. But here it is telling, take me as the smallest number, don't take all together. So what is components? Smallest number of independently variable constituents taking part in the entire reaction which is in the equilibrium state, through which we will be able to explain the composition of each phase, either directly or in the form of equation. Generally, it is this. Water system. Water exists in 3 different phases. Ice, which is solid, water, which is liquid, and water vapor, which is gas. ठीक है, अब ice को हम कैसे लिखेंगे? What formula we will write for ice? Tell me.
H2O.
What? H2O, correct. Water को हम कैसे लिखेंगे?
H2O.
Correct. Water vapor को हम कैसे लिखेंगे?
H2O.
H2O. So no matter what the number of phases are over here, solid, liquid, and gas, but all these 3 phases are just written by one single term, which is H2O. Okay, one single term, which is H2O. तो H2O अपने आप में एक ही नंबर है. H2O अपने आप में एक ही component है, which gives me the 3 different phases, solid, liquid, and gas. So here we say, though the phases are 3, component is 1. समझा? So ice अगर होगा तो भी उसको हम H2O में लिखते हैं, water है तो भी उसको H2O लिखते हैं, water vapor है तो भी हम H2O लिखते हैं. तो पूरा जो सिस्टम है वाटर सिस्टम, उसको एक ही फॉर्मूला डिफाइन करता है, वो है H2O. So this is what it is written over here in the definition, by means of which the composition of each phase can be expressed. तो solid phase है तो भी हम H2O लिखते हैं, liquid phase है तो भी हम H2O लिखते हैं, water vapor है तो भी हम उसको H2O लिखते हैं. ठीक है? So here Number of phases is equal to 3, but number of components is equal to 1. That one component is nothing but H2O. Followed? Samjha? So H2O is the constituent which is expressing the entire system. Okay? Write down the example. Don't write the definition because it is there. And I'll be sharing this presentation also right now. लिखो, लिख के हो गया, सिर्फ एक ही एग्जाम्पल लिखो, then we'll move on to the next example. If it is done, then let me know. Time is up.